Good afternoon, everyone. My name is Paul Sztorc. Welcome to my presentation about sidechain risks, the case against worrying. I'm a little biased, of course. This presentation is primarily for doubters, such as Todd, who stated at some point, merge mine sidechains are a broken idea that fundamentally means miners have the ability to steal coins and makes the scaling problem a lot worse. And then later, 2 years ago, he went on Let's Talk Bitcoin and explained why sidechains are insecure and bad for decentralization. You can pause this and read it if you want. Ultimately, it's really the argument about block size all over again, but with an even higher administration overhead. This is from the Blockstream paper, also about 2 years old. I think actually next month, 2 years old. Very old stuff. Risk of centralization of mining, we'll be talking about that. First, I think I'm going to just do 2 slides on what Drivechain is because I tried to really make some improvements upon the ideas that were published 2 years ago when I set out to design Drivechain. What it is a really simple way of two-way pegging. It's a way of moving Bitcoin in and out of sidechains. The design is asymmetric, such that everyone who wants to run a sidechain also needs to run Bitcoin. And that makes the main decide half quite easy because you just do something with your Bitcoins and the sidechain picks up on it and credits you your coins. And then when you're on the sidechain, you do various items with your coins, they change hands perhaps, and then the meat of it is that you've got to come back side to main. So you request a withdrawal, and if the withdrawal goes through, the sidechain destroys your coins. How does this withdrawal work? Well, the software behind the scenes pools all the withdrawal requests of a certain time into one little thing which I call WT prime or WT caret. That's what might look something like this. It's very small. It exists at this point in time, maybe at the beginning of week 98 hypothetically. A Bitcoin miner on the main chain, aka regular Bitcoin core, includes it in the blockchain, and then there's a waiting period to make sure that everything is kosher, where there's no stress involved with voting, it's just only waiting. And then the miners vote, in quotes, on this transaction with their hash power. And if the transaction accumulates enough work, then it goes through and these people get paid. So what you're criticizing if you don't like sidechains is you're criticizing basically a transaction such that coins are deposited to some address into like a box, and then transactions are paid out of that box according to whether or not miners accumulate enough work. So it's very similar to what we already do, which is the whole point. Although it seems to be very simple and harmless at first, it does result in transformative benefits, I think, for Bitcoin, as well as potential risks. So I'm going to try to go through that in this presentation today. And the rubric and the skeleton of this and the core of this presentation is that we're going to imagine a user that hates the idea of sidechains, and we're going to imagine how this person might suffer if they were forced to endure a world where we added sidechains to Bitcoin core. So first we're going to see to what extent can Bitcoin sidechains affect the Bitcoin main chain, and I'm going to argue that it's limited to mining effects. And then I'm going to say, well, to what extent might the mining network be affected? And I'm going to argue that this boils down to 2 things: bandwidth as well as transaction fees. Secondly, I'm going to do what I call an interlude to complain about people who complain about mining. So I think this mining centralization concept is fake and a dishonest use of the word decentralization and a manipulation of language. So I'm just going to touch on this briefly. And then I'm going to get into these 2 concepts here, these big concepts, bandwidth and transaction fees, in detail. And then finally, I'm going to have some light commentary on orphaning before reaching the conclusion. So here is the conclusion. If you don't want to watch any of this, I'll just give you all the right answers right now. My first and strongest argument is that if you don't like sidechains, you don't have to run this software. It's no different from deciding not to run Google Chrome or deciding not to install Flash or deciding, you just install whatever you want to watch If you want to play Flash games on your computer, you install Flash. If you don't like Flash, you don't install it. And so we are on really solid footing there. But unfortunately, for incentive reasons, Drivechain implies that all the miners will be installing everything. So the question is, how bad is this load that we place on miners? And I'm going to argue that it's an acceptable load because the miners get paid for running this software, and if the software is too burdensome, they just won't run it. So that's quite ideal there. But nonetheless, even though miners can't be harmed, they are transformed by the sidechain process, and so I'm going to try to explain in an overwhelming detail how these transformations might affect our hypothetical user who hates the idea of sidechains. In short, it's going to be that we've already done this once 5 years ago, and I haven't heard any complaining about it since, which is suspicious, and that miners really can't do anything to harm you if you're a Bitcoin Core user at all. My opinions are very strong on this issue. And then finally, I'm going to dissect our two big concepts in detail. And I think we're 100% safe on fees, and I think we're getting to 100% safe on bandwidth. So those are the conclusions. So without any further ado, on to part one, blockchain interactivity. Here's the agenda for this section number one. I'm going to talk about the problem. I'm going to talk about one solution, kind of in quotes, because like with all solutions, there are no solutions, right? Only trade-offs. But we'll see one that's extraordinarily conservative, and then I'm going to talk about if that solution is robust. And then we're going to talk about a different trade-off that's a lot better, I think. The problem, fundamentally, is that the more stuff we put on a blockchain network, or any network of any kind, the more resources will necessarily be required. Now, with sidechain, that's the problem that sidechains are really designed to solve. So if you don't want to run, let's say this is Bitcoin over here, and these three are the Bitcoin miners, and someone invents something cool like Monero, and we add it as a sidechain of Bitcoin. You might say, I don't want to run Monero, just like you would want to run you would want to run Flash or something, and that's your choice, right? And so that's very desirable for a lot of reasons, because now it's up to the developers at Monero to convince you that it's worth it. It puts power right back into the hands of the users, which is really the whole point and the magic that makes all this beautiful and amazing. But the trick is, for incentive reasons, all the chains are going to have to be merge mined, in my opinion. And so it becomes quite appropriate to divide the analysis into node costs and mining. So there's a key difference here that miners get transaction fees and they have to run everything, whereas nodes are opt-in. There's no compulsion to run every chain. This is quite nice, and I have these skulls that represent the anti-fragile concept that if someone invents Monero 1.0 and something horrible happens to it and it explodes, we can use that information to build Monero 2.0, and you can wait on the sidelines until you're happy with 2.0 or 3.0 or whatever. So the whole system as a whole can get stronger and stronger by trying things out with real Bitcoins that can be stolen, or real networks that can be attacked or tested in the real world. So there's a lot of great stuff. The node costs are 100% solid. It's fully opt-in. All the costs are internalized. But the issue is that these three must share the mining network. So we have to ask ourselves, what do miners do? How might we destroy this process? I made this slide a long time ago, and I kind of regret the complexity of it. So I'm just going to say that miners take certain things, hardware, but not only hardware, but know-how and software, and they add in operating costs such as labor and power, most importantly electrical power, of course, and they have network costs. In order to mine, they need the current block header, and they need some incentive. So they either need the block subsidy, which is the 50 Bitcoin, 25 Bitcoin, 12.5 Bitcoin subsidy, or they need transaction fees. And in order to earn transaction fees, they need to know that those transactions are valid. And that's an important thing we'll come back to, because it's especially relevant for sidechains which cannot have the subsidy, because sidechains must respect the 21 million coin limit. I mean, if they're to have any sane design at all, I suppose you could theoretically have a side, but it would be no. I doubt anyone would use such a thing. So here's this diagram from before that I had. We have Bitcoin that we know and love, and then we add our first sidechain, hypothetically, Namecoin, and these are little beads of sweat. The miners now need to keep up with both networks. But, okay, here's a diagram of this. Pre-sidechain, post-sidechain, we go from this left rounded rectangle to this right rounded rectangle. Inputs come into this capital structure, and the fees come out. This is kind of a little tiny diagram to kind of capture the whole picture here. 12.5 Bitcoin is the block subsidy, and 0.1 I'm just assuming are the transaction fees. I just invented that. I'm inventing for Namecoin that there's going to be 0.3 transaction fees per block. This is just invented by me. And I point out that with merge mining, you do not actually need any additional power, and you don't really need any additional capital. You do need the software from somewhere, but other than that, you don't need anything. What I'm pointing out here is that there's new fees that come in almost for free. Not quite for free, because you have these new node costs. So as I was saying before, miners are offered this software, and if the software costs too much, it will just be rejected. So I define this value of a sidechain option as the transaction fees that come in minus the expected new node costs. Hypothetically, they're all positive here, and I just invented these: Namecoin, Zerocoin, Rootstock, whatever, per block. This is all just made up by me. But I just wanted to highlight the idea that if a sidechain is more valuable to users, more money might come in. If it's more complicated, there may be higher costs, storage, RAM, CPU, whatever. And so we have another line of protection here, which is that if this option is negative, then the sidechain will just be ignored. So you can imagine a hypothetical YouTube chain that requires giant HD storage and some kind of crazy nonsense, huge bandwidth costs, huge RAM costs, whatever. We have another line of protection, which is that the miners just can say no. Not only is it opt-in for nodes, but it's in some sense opt-in for miners. But this creates its own problem, which is that if the sidechain is profitable, all of the miners will ultimately need to be running this software. So as Don Corleone would say, it's an offer you can't refuse. So let's say you see this miner is not connected to Monero or Namecoin in this fake example that I've just invented right now. These guys are getting extra money in the form of transaction fees, but this guy is not. And that it's the equivalent of having a better ASIC design where the same power expenditure and the same inputs go in, but a higher revenue results for these individuals. So this guy will either have to conform or he'll get pushed out. He'll get fired by the protocol. So here's from the Sidechains Blockstream paper. Miners that provide work for a subset of blockchains are compensated less. Smaller scale miners may be unable to afford the full cost to mine every blockchain. It could be put at a disadvantage compared to larger established miners. So I attempt to address this concern, but I only half address it. What I mean by that is any sidechain that's profitable, all the miners must run. So I protected the miners when they're not being rewarded enough. But if the reward is positive at all, eventually they'll all have to get on board. So as the revenues increase, the miner must go from mining 1 to mining 2 to mining 3. And this causes the sidechains to affect the Bitcoin miners, which is, for our hypothetical person that was supposed to be very angry about sidechains and not like them at all, this is where their argument, I think, begins. And we're going to see how we can play around with this effect to try and minimize it or shove it somewhere else or do something else with it. So now I'm going to try to remind everyone about what I presented previously. This slide as well as the next slide are from my previous presentation, which are about the ecology of smart contracts. Some people proposed in the past that we would just throw a switch and this would enable transactions of arbitrary complexity to be included into Bitcoin, which would only validate the work on the sidechain. And so Bitcoin would have a hands-off approach to the sidechains. I think that it would be a disaster, and I strongly oppose that. This is a substantial improvement over where I think the sidechain conversation was in the past. It's opt-in for the miners, and it's opt-out in a continuous sense. So if the sidechain starts misbehaving in unexpected ways, we can just shut it off. And again, this is from my previous presentation. I'm just going to quickly remind everyone that I've designed Drivechain so that these Bitcoin miners must sign off on all the transfers that come back this way. And for full details, you should watch that presentation. But this general philosophy solves a lot of problems. Nodes just validate and miners just mine. Miners can drop sidechains they don't like. This includes if they have burdensome node requirements, as I tried to already explain, but it also includes if the sidechain is doing something that somehow threatens the fungibility of Bitcoins or the privacy of the miners. Like if some kind of sidechain is giving away the miner's location and they are trying to keep their location a secret, like their geographic location or whatever. The point is that I don't need to predict what it is that miners might not like. If they don't like the sidechain for any reason, they're free to pass on it. And then again, this is ideal because it's now up to the designer, the Monero developer / designer, to make sure that the miners will like the sidechain. So that's ideal. This is again this is from the Blockstream paper, and this is again one of the many ingredients. That paper is like a giant supermarket full of ingredients, and this is one that I've chosen for my recipe, the Drivechain recipe, which is that the recipient chain might only unlock coins given an SPV proof of 1 day's worth of its own proof of work, which is this idea over here. So again, I think it's a lot better. But let's now talk about this trade-off here, that the miners getting paid more and sweating more. So one thing we might do, one way we might address this trade-off, is we might take the rules for Bitcoin, these resource limits here that we've had for a while, the 1 megabyte block size limit, the infamous 1 megabyte block size limit, and the SIGOPS limit and other limits, right? And we could create a global limit for all sidechains. And this would necessarily limit the total burden to exactly what it was before. And we could do all this with soft forks. Obviously, the bad news is it should be quite obvious that now Bitcoin is literally affected. So our hypothetical individual might be upset that they had 1 megabyte of Bitcoin space per block before, but now they only have 0.9. And they might not like whatever this is, blue Bitcoin space. But we'll talk about that later. I just want to point out that this is totally soft fork compliant. It's a soft fork to add the sidechain A. It's a soft fork to go down from 1 to 0.9. So it's soft fork number 1, soft fork number 2. And this whole thing can actually be enforced with a soft fork-like agreement. If anyone tries to break the agreement, miners can pre-agree today to just steal the sidechain Bitcoin's deposits. And what this agreement to steal does, if the miners are planning to honor their agreement and steal the coins, it will be very difficult to get users to deposit coins in the first place, which means that we're in a stronger equilibrium of just no one breaking this agreement. Let's say the miners are evil. They don't care what any developers or users say. They're going to add a new sidechain. And so again, I want to point out, in Drivechain anyway, you have to have a soft fork to add each new sidechain. And believe it or not, there is actually a mechanism to prevent this from happening over here. It's prevent the sidechain from hard forking. And if it hard forks, it will no longer by default be tied to the Mainchain Bitcoin. Now again, since the miners are kind of in charge of signing off with their work, I'm not sure how relevant this is, but there is a mechanism to prevent it from happening in the code. So you got to soft fork this if you want to make improvements, or you have to redo and do a new soft fork later from the main chain. I'm sorry, did I explain? This is the main chain, orange, it goes along. And then we soft fork it to make one sidechain number 1. And then I'm saying this is impossible. You cannot hard fork the sidechain any more than you could hard fork the main chain. But what if the miners say we're evil and we want to soft fork either side 1 or the main and create a new sidechain, green sidechain 2, and that is going to have something that exceeds this umbrella limit here of 1 megabyte per block. And what I say to that is that it doesn't matter, really. It's almost no different from the miners agreeing to randomly send each other files and then add those files up and then subtract from them and then send them back to each other. So it's not affecting you. It's only the miners are affecting each other. So this is this limit here, this trade-off that we're going to be exploring throughout the presentation. In order to trespass this limit, you need the miners, of course, and you need users who pay fees. Otherwise, this is a completely pointless exercise in sending files among miners. And third, you do need code to have been written by developers, and I think it's easy to dismiss this point, right, as fragile and just say once someone writes the software, Pandora's box has been opened, and this ability to veto is gone forever. But I think that it's not. I think it's foolish to write it off. We all know how difficult it is to write this blockchain software, and all software has bugs, and Bitcoin has had bugs, and money is at stake, so those bugs will be found. And I just think that it's foolish to write this off. This is actually a very powerful requirement that someone has to write this software. People often talk about writing software, but they never get around to actually doing it. So again, as I've been trying to explain, the Bitcoin users and people who run node software are not affected by any of this, but it's only the Bitcoin miners that affect each other for the duration of this transgression. And again, I'm not going to I call it a transgression and not an attack, because right now we're at such a high level of abstraction that one man's attack is another man's killer app, great feature. So the fundamental question is, how interdependent are mining activities? Now this is a slide you may remember from the conclusions preview, and I'm just going to refer to tame sidechains as ones where we've respected this global umbrella limit, which I'm going to go back to right now, this global umbrella limit thing here. And these have a lot of benefits already. We are able to add new features to Bitcoin. The contracts are firewalled from each other. They're opt-in and they don't affect each other. So what I'm going to be calling wise contracts instead of smart contracts. They're even better than smart. They're wise, because they're firewalled from each other and they can't damage each other, which is, I think, wonderful. These contracts are managed to maximize Bitcoin's value because the miners control them, and the miners are Bitcoin value maximizers. They are paid in Bitcoin. They want to get paid as much as they can, just like everyone else. So I draw a distinction between the umbrella limit and what I'm going to call aggressive sidechains, which go past these limits. And so I think we get all the benefits of the tame sidechains, and we get this magical phrase, permissionless innovation, which is something that has made the internet so wonderful. And I just wish we could bring it back into Bitcoin. It would really resolve a lot of conflict, and it would restore an atmosphere of cooperation and mutual assistance and growth and everything wonderful about the world, right? So I think we should go for this. In addition, we benefit because there's no debate over like the split. Like someone says 0.9, 0.1 should be the split, and another person disagrees and they say 0.85, 0.15. Another person says, why are we splitting at all? I hate blue Bitcoin, it sucks. So this debate could be kind of annoying. I say we avoid it. So that was the intro. Part 1 is almost over. 5 more slides. The problem is that more resources must be consumed by someone, and it's almost completely opt-in, but it's not completely opt-in. There is some element of compulsion in the miners, and I talked about one way of addressing that trade-off. And now I'm going to say a different way, a different theme of addressing that trade-off is to just ignore it. So I've identified 3 resources or resource categories for mining: capital, operating, and network resources. And those resources combine to produce revenues for miners. So right now, I'm just going to tell you that revenues will get its own section. Do the revenues of one chain affect another chain? Because that's quite an important topic that deserves its own section. And what I was going to do here is make a big table of all the interacting effects, but it turns out that don't waste too much of your brain power loading this table into your mind, because most of it is irrelevant. So I have a red flag here for software, which is that like all Bitcoin related software, if someone could sneak in malicious code that steals miners' Bitcoins, but that's no different than any other soft fork or any other piece of software written by anyone. But in general, it's very hard. These things. So merge mining, by hardware here I mean ASICs. By power I mean electrical power, not the more interesting kind. And so with merge mining, these two are they don't interact with anything. You could share the hash rate for free. And this comes with its own risks, and I've discussed this on the Drivechain blog design, so I'm not going to discuss it here. But we get to share the hash rate for free, so we get all this stuff for free. It's not significantly costly, in my view, to run more software. Software is usually handed down from the developers. And I really don't think it's more burdensome on individuals who manage a mining rig or a mining pool if they could learn how to do it once with Bitcoin, and they could learn how to do merge mining once already with Namecoin, which about half, 55% of the network already did. I don't see how it would be more difficult to continue in this direction. These network costs are way more interesting. So first of all, we might need more storage and mundane junk like that. I'm not worried about that at all. There's typically huge economies of scale for that type of thing, where there's a hard drive is not completely used up, and so you can share, and it's very, very, very small effect anyway. But this bandwidth idea is really something else, and it's endlessly fascinating, and it will get its own section. But I'd just like to point out these are the only two major categories of miner interdependence that I could locate. So if you think another one is significant, feel free to comment on the video or make your own video or do whatever you like, or write a blog post or something. So here are quickly the conclusions. Sidechains convert miners. They get paid more, but they have to work more. Nodes are safe. Miners are not harmed, but the miners are changed. They have to absorb profitable sidechains in the long run. Total effect is limited to this mining conversion. It's possible to set the total effect to 0. That's one way of addressing this trade-off. And then in the worst case, when we breach and we do the aggressive sidechains, trespassing the resource limits will cause miners to affect each other, which they can do in basically two ways.